All right, so first off, on the first warm-up, I would factor out a 6x. That leaves me with x squared minus 7, right? 6x cubed, checking it by multiplying it back in, 6x cubed minus 42x. X squared minus 7 is not it's a perfect square for the x squared, but it's not a perfect square in the 7, so then my answer is just that. Can't go any further on that one. Okay. On second F, factor first out a 2x. That leaves me with x squared minus 16. Now, here on this one, x squared is a perfect square, 16 is a perfect square, and most importantly, I have a subtraction sign there. So this becomes 2x and x minus 4, x plus 4. Okay. When we factor completely. Yes, the green line is factored, but it's not factored completely. Okay. Next one here, no GCFs to speak of, so I need to factor it using the double parentheses. You'll probably hear me refer to it as the butt cheeks. Okay, x squared and x squared there. Two numbers that multiply together to be positive 6 and add together to be negative 5. Negative 2 and negative 3. Okay. Neither one is a perfect square minus a perfect square, so then that is my answer. I can't factor anymore. Over here, again with the butt cheeks, x squared and x squared minus 6 and minus 6. Get me that one? Yeah. So I can write that in pretty form as x squared minus 6 quantity squared. If I left it as the green form, I'd be okay with that too. In this case, right? In the other cases, in the one right above it actually, up here in the second one, not okay with leaving it in the green form. All the rest of them are okay with the green forms. Okay? Any questions on that stuff? Okay. So yesterday we dealt with the four of the ways of factoring. Okay? We had GCF, which by the way, you should always GCF first. Okay? That's the first thing you look at. Is you GCF if you can GCF the whole thing. That's your very first thing that you're going to look for. Okay? So we did that one yesterday. That was why we did that one first. Second one we did was difference of perfect squares. Okay? Recognizing the perfect squares. Okay? And then that there's a subtraction sign in between them. Then we did just regular old trinomial ones. Okay? Then we did regular old trinomial ones that just happen to be perfect square trinomials. Okay? Well, we can do them in the exact same way. Okay? So we are 2/3 of the way done with our ways of factoring. We've got 4 of the 6 ways to factor done. Today we're going to hit up the 5th way. Tomorrow we're going to take a formative. Friday we're going to hit up the 6th way. Okay? All right? So the 5th way is called factoring by grouping, which is on your note sheet now halfway down the top page. Sometimes polynomials have more than 3 terms. Okay? The first 4 ways work for 2 or 3 terms, but the only thing that works after that is greatest common factor. Okay? So when we have 4 terms, we still need to check for a GCF first and look for common factors. So we look at the whole thing first. work for any even numbered term polynomial. So like in this case, I have a 4-term polynomial. It would also possibly work for a 6-term polynomial or an 8-term polynomial. Okay? Now, Colt here factored by grouping. Okay? So above the red line here, is factoring by grouping. Okay? Below the red line is just complete factoring. Okay? But above the red line there is factoring by grouping. Let's look and let's explore what Colt did. He did it right. Okay? It's good. I know it's good because I've got the thumbs up from Colt. Okay? So I know it's good. But let's look at what he did now. So we started with the expression, right, that we're factoring, or we started with the function that we're factoring. Okay? In this first step, what did Colt do? Looking at it, what do you think Colt did? He GCF, but there's no greatest common factor for all of the terms. So we can't just say that he GCF'd the whole thing. Of where? Where did he GCF? All right, so what did Colt do? What do you got, kid?
Okay, so Eric and I were thinking that maybe he chose to like separate the problem because you could take an x squared out of the.
How did he separate the problem?
So you put the parentheses in front of.
He cut it in
half.
He cut the problem right in half. Okay? So that's the first thing that he did is he cut it in half. Okay? Then what did he do? On the left half, the first half, if you will. He GCF'd an x squared, right? Okay? So he GCF'd the first half. I don't like writing lowercase letters. I gotta fix that. Come on, Lensmeyer. Okay? So that was this part right here. He took out an x squared, and he's left with x plus 3. Okay? What else did he do in that first step? He GCF'd the second half. And he took out a -1, right? Okay? So you take, in factoring by grouping, you take your polynomial and you divide it in half. You GCF the first half, then you GCF the second half. Okay? Hopefully, if it's factorable, then you can go to step number 2. What did he do in step number 2? Nope. What did he do in step number 2? Step 1, he GCF'd the left half and GCF'd the right half. What did he do in step number 2? What did he do?
Okay, so I think he did the x plus 3 times the GCF because he has x squared and -1.
He did not do the x plus 3 times the GCFs.
Okay, wait. Should I put it a different way, like factoring?
What did he do? What if I wrote this as, what if this problem was, let's go purple. Let's Let's go with W because it covers everything up. What did he do? He did not combine like terms. It's 3 letters, people. GCF. He GCF'd. Okay? He GCF'd again. Let me get rid of my W's now. Okay? He took this whole new factored line that you just got done in step number 1 by factoring, and he factored out the greatest common factor. The greatest common factor is there's an x plus 3 in each of those terms. So he factored out the x plus 3. What's left over if he factors out the x plus 3? Well, from this first term, he's got an x squared left over, right? And from this second term, he's got a negative 1 left over. Okay. So factoring by grouping is really what? What is factoring by grouping? Because now we're at that red line. There's the red line from up above. What is really factoring by grouping? But 3 GCFs. Okay. Then he went on and he factored completely. Because he saw that x minus 1 here is a perfect square minus a perfect square. So it's a difference of perfect squares. So that one becomes x minus 1x plus 1. Okay, with me? Let's try another one, which is number 1 on the back side of your page. Okay, x cubed plus 7x squared minus 4x minus 28. First step was what? So really the first half of the first step was factor GCF factoring the first half of the problem, right? Okay, so x cubed plus 7x squared. I'm looking at that. What can I factor out of just that? I can factor out an x squared. What's left over then? X plus 7. Okay? Whoa. Let's just restart. Then, what was the second part of step number 1? GCF the other half, right? Okay? Now, the kicker is you're going to look at that sign right there. Okay? If that sign there is positive, you're going to factor out a positive number. If that sign is negative, you're going to factor out a negative term. Okay? So what are you going to factor out there? Negative 4. Okay? If I factor out a negative 4, then that leaves me with x plus 7. Okay? I want that and that to be the same. Okay? We need those to be the same because the next step is now we're going to factor that out. X plus 7. What's left over? X squared minus 4. Can I factor any more? Yes, go ahead, Ken.
There would be a time where the x plus 7 and x plus 7, those wouldn't be the same.
If that is, then you did something wrong. Or it can't be factored by grouping. So yes, that is a possibility. Okay? So if that happens, go back and check to make sure you GCF'd right. Okay? And if you GCF'd right and they're still different, then it just can't be factored by grouping. You gotta go a different way. Okay? Right? Am I factored completely? No, why not? X squared minus 4, this is a perfect square, that's a perfect square, and that's a subtraction sign. So to end this off, we would go x plus 7, x minus 2, x plus 2. Okay? What I'd like you to do now is I'd like you to do the next 5. Talk to me. Number 2. X squared. Okay, what's left over? X minus 6. Okay. Next half.
8.
What's left over?
X minus 6.
Whole thing.
X minus 6 and x squared plus 8.
Can I go any further?
No.
Any further on that one? Nope, can't go any further on that one. That's my answer. Okay. This one, number 3.
X squared.
Left over?
X minus 6.
Sure.
Oh, wait, minus 2.
Minus 2.
No.
Okay.
3 and x minus 2.
So then that gives me,
X minus 2, x squared plus 3.
can I go any further? No. This one?
X squared.
Left over?
X plus 1.
X plus 1. Very good.
Negative 4.
Left over?
X plus 1. X plus 1 and x squared minus 4.
Okay, can I go any further?
Yeah. X plus 1 and then x minus 2 and x plus 2.
Good job. Because that's a perfect square minus, x squared minus 4 is a perfect square minus a perfect square. So we have to go further on that one. Okay? Somebody other than Travis now on this next one.
X squared.
X squared, what's left over?
X minus 6. Minus 9.
What's left over?
X minus 6. X minus 6. X squared minus 9.
Can I go any further?
Yeah.
What does it go to?
X minus 6.
Yep.
X minus 3.
Yep.
X plus 3.
Yep. Okay. Good so far on those 4. Yeah? Okay. Number 6. First. No.
You can't do it.
With what? The axe first. Okay? GCF the whole thing first. Now, what? Now we can factor out an x squared. X minus 4, right? And here, negative 1. And then x comes along for the ride. Can I go any further?
Probably yes.
Because x squared minus 1 is perfect square minus a perfect square. So in the end, I get x times x minus 4 times x minus 1 times x plus 1. Now, when I was walking around, I saw a lot of what you guys had started to do. So the original problem was x to the 4th minus 4x cubed minus x squared plus 4x. And you said first, factor out an x cubed. And that leaves me with x minus 4, right? And then you said factor out a negative x. And that leaves me with x minus 4. So then if I factor out an x minus 4, I'm left with x cubed minus x. What don't I like about x cubed minus x? You can GCF an x, right? So then this becomes x minus 4 times x squared minus 1. What don't I like about x squared minus 1? You can still factor it. So then it becomes x minus 4 times x minus 1 times x plus 1, which if I rewrote it, put that x out in front, gets me right to that. Okay? So you get to the same place. Okay? But you got to go through a couple of crazy steps. A lot of people stop here. A lot of you, as I was walking around, stopped there. Okay? Okay? When I go to Florida at Christmas, okay, if I stop in Milwaukee, am I in Florida? Okay? I'm on the path, right? I'm in the general direction, okay? But I'm not in Florida. Okay? It's a lot warmer in Florida than it is in Milwaukee. Okay? Know what I mean? Okay. Bonus factoring question. Both students factored correctly. I know that because there's a thumbs up. Okay, what's the difference between the two solutions? Mull that one over for a little bit. They both got to the same place, right? Rex had stopped. Kenny went on. What's the difference? Is Kenny's right? Yeah, it's got the thumbs up. I mean, it's right. But do we do that? No. Technically, yes, this is right. And I can factor x squared plus 4 as x plus 2i, x minus 2i. I can do that. Okay? But what this is saying is we only do difference of perfect squares. Okay? We don't do sum of perfect squares. That's how you would have to factor the sum of a perfect square. And we don't like to go into that imaginary world. Okay? Alright? Blue is your homework tonight. It will be due tomorrow. You also have a formative assessment tomorrow in class.